Hi, I'm Ron Covell. This is the third in a series of videotapes about metalworking. This video is about working with tubing. What's in front of me here is the chassis for a half midget I made out of small diameter steel tubing. In the video we'll take a look at lots of different ways of working with tubing for many different applications. If we start with a bar of solid metal and hollow out the center, we remove much of the weight, but the remaining hollow structure still has great resistance to bending and twisting. Even if only a very thin shell is left, the strength is very strong, although we have removed much of the weight compared with a solid bar of the same size. This is perhaps the chief reason we see tubing used so much structurally. Also, tubing is often used as a conduit for all sorts of liquids and gases: exhaust gas, nitrous oxide systems, compressed air for smog abatement, fuel lines, brake lines, vacuum lines, instrumentation, fire extinguisher systems, and on and on. Tubing has many ornamental uses as well. We often see it used for bumpers, Nerf bars, grills, sculpture, and thousands of other uses. Before we go any farther, I want to make a distinction between tubing and pipe. Pipe is designed for running fluids or gases through. It is generally made of a lower grade material than tubing, and it is measured by its inside diameter, or ID, while tubing is measured by its outside diameter, or OD. Perhaps the most common example of pipe is galvanized iron water pipe, which is joined by threaded couplings. While this is relatively inexpensive material, it is great for piping water into people's homes, it is a very poor material to use for making structures which could jeopardize people's lives if they fail. It just doesn't have very good mechanical properties when compared with steel tubing. We'll be working solely with tubing in this video. Tubing comes in an amazing selection of sizes and shapes. Here are just a few random samples off of my tubing rack. This is a piece of stainless round tubing, smaller diameter stainless round tubing, aluminum round tubing, chromoly steel round tubing, brake line tubing, aluminum streamline tubing, chromoly streamline tubing, a couple of different sizes of chromoly streamline tubing, oval mild steel tubing, aluminum oval tubing with flat sides, steel square tubing, aluminum square tubing with square shoulders, rectangular steel tubing, and the list goes on and on. Tubing comes in an enormous range of sizes. The largest piece I had in my shop the day we shot the video was 6-inch diameter, and I've placed it right next to a hypodermic needle, which has a needle point made out of 20 thousandths diameter stainless steel tubing. Let's take a look at some different kinds of tubing. This is probably the most common type of steel tubing. It's called electroweld tubing. If you look closely, you'll see a dark stripe going all the way down the length of the tube. That's actually a weld. This material starts as a flat sheet, and they roll it into a circle and then continuously weld the seams shut. And actually, it's quite a good product. This is what you'll see the most of in the world. The tube next to it is called DOM tubing. DOM stands for drawn over mandrel. This is made in a similar manner. They roll a strip into a circle and weld a continuous seam, but then it goes through one more step in the processing. It's drawn through a die and pulled over a mandrel that fits tightly inside the tube at the same time. And this does a couple of things. It flattens out the weld on the inside, and also it sizes the tubing very precisely on both the OD and the ID. Also, they use a little higher grade of steel for DOM tubing. This is a piece of seamless tubing. This is a very high quality product. To make this material, they actually start with a solid bar of steel and then force it at high heat under great pressure over a spear-pointed mandrel, and it actually hollows out the tube and makes a tube without any seam whatsoever. It's quite a bit more expensive than the other grades of tubing, and it is slightly stronger. All chrome moly tubing is seamless, and some mild steel tubing is available seamless. This is a piece of aluminum square tubing. Aluminum tubing is almost always made by an extrusion process. And this is a piece of steel square tubing. It's interesting that the way they make steel square tubing is to first make steel round tubing, and then they pull it through a special die head, which forms it into the square shape or into a rectangular shape. So we'll be looking at lots of different ways to work with tubing. I'll be demonstrating different techniques and some different tools as well. At the end of the video, I'll give a complete listing of all the manufacturers and suppliers of the tools I'll be using. So let's get on to the demonstrations. For the first demonstration, we're going to do some work with small diameter tubing. This is the sort of tubing you would use if you were doing brake lines or fuel lines for an automobile or airplane. And this material is very thin wall, very easy to work with. The first technique I'm going to show is the use of a tubing cutter. Very handy tool for parting pieces of this material. To use this tool, you loosen it until it fits over the tubing, and then you tighten it until the cutting wheel just barely touches the tubing. Then you rotate this around the tube, tighten it a little bit after one rotation, make a second rotation, tighten it a bit more, tighten it a bit more, and very quickly it will make a very clean cut in the tubing. Now you'll see that there's a slight burr that's left after the cut is made. These tools have a feature which is used to deburr the end of the tubing. You simply put that in the end of the tube and twist it, and it does a nice job of cleaning up the burr. So that's how the tubing cutter is used. The next tools we're going to demonstrate are tube bending devices. We have three different ones here, each designed for a different size of tubing, and there are many other sizes available. I just wanted to show you these three as examples of the types that are available. We're going to be bending 3/8 OD tubing, and the way these devices work is you open the tool up, there's a place where the tubing slips into place, and then by squeezing the levers together, you can make a very nice even bend in the tube. And in fact, the tool even has a scale on it so you can measure the angle of the bend that you're making. So I'll stop at 90 degrees here and release the tubing. And there we have a very nice bend. The last demonstration we'll be doing on small diameter tubing is the use of a flaring tool. Flares are put on tubing which needs to hold pressure. These are common for fuel lines and brake lines. The particular type of flaring tool we'll be using is designed to put what's called a double flare on the end of a tube. A double flare is folded over so it has two thicknesses at the sealing edge. These devices come as a kit. It's sized to work for tubing between 1/2 inch and 3/16 of an inch. And there are several different devices that go with it that allow you to put that double flare in different sizes of tubing. For convenience, we're going to mount this tool in a vise, clamp it very tightly. Then the body spreads apart. The tubing is inserted into the slot that matches its size. There is a particular button that's used for each size of tubing, and there is a flange on this button that lets you know how far the tubing should protrude above the top surface of the device. Then the clamps are tightened. They must be very tight. The button is placed inside the tubing. And there is a clamp which starts the double flaring operation. So you tighten it as far as you can in the first operation, pull the button out. At this point, the tubing looks like this. It has kind of a mushroom head on it. And after the button is removed, then the pointed tip of this clamp is placed into the tubing. You continue the tightening. Go all the way down, and then back the tool off. And then you can remove the tube. And there you have a double flare, very strong and very smooth. Before I forget, I should mention that you should always put your fittings on the tubing before you do the flaring. Many times the tubing that you'll be working on will need to have a rubber hose slipped over it and be held in place with a hose clamp. And a very useful way to deal with that situation is to put a raised bead on the tubing. There's a special tool made just for that purpose. Let me show you how it works. We're going to clamp this in a vise just for convenience. Then the tubing is carefully prepared. It must have a clean cut edge, and it needs to be deburred very carefully on both the inside and the outside. You need to put just a few drops of oil on the inside of the tubing, and then it slips into place on the machine. The handle is tightened down just a little bit and turned through one full rotation. And there you have the bead, very nicely formed. 5/8 OD is the smallest tubing size that will work on this machine. And of course it will work on tubing of any size as long as it's larger than 5/8. Let's do a piece of steel tubing now. This is 1.5 inch diameter. We'll put a little oil on it. Go through one full rotation. Tighten the clamp a bit more. One more full rotation. Tighten it a bit more. And there you have your bead. This is 5/8 OD 065 wall tubing. If you're not familiar with the nomenclature, that means the outside diameter, or OD, is 5/8 of an inch, and the wall thickness, the thickness of the metal that comprises the tubing, is about 1/16 of an inch, 65 thousandths of an inch to be precise. And that means the hole in the middle is 1/2 of an inch in diameter. Our goal is going to be to put a bend in this piece of tubing, and we're going to do it in the simplest of ways. I'm going to simply put one end of the tubing in a vise and pull on the other end. And if I work carefully, I think you'll be able to see that we can make a very nice, even bend. I'm just kind of gauging with my left hand where the bending is happening. This is the freehand bend we made. It's a nice smooth bend, but if you look closely at it, you'll see that the radius varies a little bit from one end to the other. There are times when you might want a variable radius bend, but for the next demonstration I'll show you how to make a more consistent bend. I've made a simple fixture by just welding together some scrap pieces of material. There's a steel round here about 5 inches in diameter. It's welded to a vertical plate about 3/4 of an inch thick, and there's a 1-inch square bar welded to that. And this whole assembly is held tightly in the vise. So the way we use this fixture is I slip the tubing between the square bar and the round and simply pull the other end of the tubing around. And I think you can see that this bend is much, much more consistent. It doesn't have the variations that the freehand bend does. For the next demonstration, we're going to bend some larger tubing. This is 7/8 OD 065 wall steel tubing. This is right on the borderline of what's easy to bend by hand. If you're a 300-pound lumberjack, you probably can bend this without the use of heat. I'm a little lighter than that, although I'm gaining, and I'm going to use heat to soften the tubing, make it easier to bend by hand. I've made a little device here. It's basically just a piece of channel with some dividers at each end. And what this channel does is it catches the flame that goes past the tubing and redirects it up underneath the tube. So it helps capture some of the energy that would otherwise be lost. And we can heat the tubing more quickly using this fixture. So I'm using a rosebud tip, not the acetylene torch. My goal is to heat this tubing bright red. And I'm trying to heat it as evenly as possible. You can see it's a dull red right now. We want to go right up until it's a very bright red. Okay, we're getting a nice bright red color now. So very quickly, I'm going to extinguish the torch, pick up the tubing, hold one end in the vise, and then simply pull on the other end, making a very smooth freehand bend. We'll release the vise. And there you have a freehand bend. Actually, bending this way tends to ovalize the tubing somewhat. It tends to get a little wider in this direction and a little thinner from top to bottom. And if you have a smooth jaw vise, while the tubing is still warm, you can actually flatten the tubing out a little bit to make it slightly more round. There's our freehand bend. For the next demonstration, we'll be doing a variation of the hot bending technique. In this case, we'll be using a very inexpensive form made of MDF, or medium density fiberboard. You could also use particle board or even plywood for this technique, and it would work as well. Basically, I've used a saw to make a curved cut on the edge of this piece. I used a bandsaw for this cut, but you could also use a saber saw or scroll saw. I've sanded the edge smooth, and the form is held, in this case, in a vise, although you could hold it in many other ways. Since we're going to be bending the tube hot, it's important that you protect the edge of your form with metal. In this case, I've simply put a piece of 60,000 steel on the edge. Just a thin strip of sheet metal is all that's required to keep the board from burning. And the metal strip is held in place with screws on each end. This is the tube we'll be bending. I'll heat this tube in our trough and then bend it around this form. Okay, I think we're just about ready. Here we go. Quickly, we'll put it in the form. And there we have it, a nice, smooth, gentle bend, made over a very inexpensive form. Now this form is something you can use quite a few times. Obviously it won't last forever. Eventually the heat of the tubing will deteriorate the material at the edge. But with this band of metal screwed to it, you could probably make 10 or even 20 bends on a form like this. For the next demonstration, we're going to go up one more size in tubing. This is 1-inch OD 065 wall steel tubing. All the tubing I've used so far has been 065 wall except for the brake tubing, which was thinner. These same techniques work fine with 1/8-inch wall, even with 1/4-inch wall, although the heating will take longer with the thicker walls. And we've set up a bending fixture here just using found objects. There's an aluminum round I found at a scrap metal yard, and I've clamped a bar on my table which acts to support the end of this tube once I have it in position. Now we're making a fairly tight radius bend in some fairly large tubing. We won't be able to do this cold. I'm going to have to use heat, and if I just use heat on empty tubing, when I try to bend it around this form, it's going to ovalize quite a bit. To help minimize that, I'm going to fill this piece of tubing with sand. I've already capped one end of this tubing. I have these caps made for me by a precision sheet metal shop. You can cut them out yourselves with hand shears, but I do this quite frequently. So I just have them stamped, and it's simply laid in place on the end of the tube and fusion welded into position. Now that I have one end capped, I'm going to use just regular sand to fill this tubing with. This is sand I got from a building supply store. I must caution you, if you're using sand to fill tubing with for heating, the sand must be absolutely dry. Let me tell you why. Any moisture content in the sand can become very dangerous. When the sand is heated, that moisture turns into steam. When water turns into steam, it expands dramatically, and it will generate huge pressure inside the tube, so much so that it can make the tube actually explode. And there have been many unfortunate accidents caused by this. So when I got this sand, I baked it in the oven to make sure it was absolutely dry. And I keep it in a sealed container. This is simply a can that used to hold hand cleaner. It has a tight-fitting lid, so it never has a chance to gain moisture from the air in my shop. So I use a little scoop, just an old plastic cup, to help fill the tubing. I use my hand as a funnel, and we'll just start pouring sand into the mouth of the tube. Okay, the tube seems to be filled now, but we'll tamp it, and the sand will pack itself together. I put a block of wood on my floor so I don't make chips in the concrete floor. I've tamped it down about 2 inches now, so I'll keep adding more sand. Filled up to the top again. I'll tamp it. It's gone down about a 1/2 inch. I'll refill it one more time. Tamp it again. It's down about 1/4 of an inch. I'll fill it one last time and tamp it. Maybe I'll top this off just a hair more. Okay, the tube is nicely filled with sand now. The next thing I'll do is to put another cap on the top of this tube, and I'll just fusion weld it closed. So we have the caps welded in place on both ends of the tube now. The next thing I'm going to do is position this in the fixture and note the point of tangency where it touches the aluminum round. I'm going to mark that spot with some soapstone. And then I'm going to simulate how this will bend around the aluminum form. I'm planning on making a 90-degree bend. I'm going to mark where the bend stops. These two marks designate the section that needs to be heated red hot. So I'll put this in our little trough, our heating fixture. We'll get the rosebud tip, get a nice big healthy flame, and heat this red hot. Working quickly now. You want to get it in the fixture while it's still bright red hot. Just gently pull it down over the fixture. And there is our bend. Now I hope I don't have to mention this, but obviously the tube is very hot at this point, and it will stay hot for quite a few minutes. So what I generally do is just put a part like this under my workbench to allow it to cool down. And we'll pick it up in a moment. So here's the finished bend. I've sanded some of the scale off it and discoloration, so we're down to the bare metal now. And you can see this has made a beautiful bend. It's every bit as nice as what you could expect from a machine bend. So again, this shows how you can use very inexpensive tools to do some very high quality work. The demonstrations we've done so far have been on bending round tubing. I want to show you a couple of examples that show how other shapes of tubing can be bent. This is a piece of streamline tubing, which I've bent by packing with sand, capping the ends, and bending, in this case, over a metal form. And you can see that it's made a very beautiful, very smooth curve. Actually, this is a test piece I used for some bumpers I made for an automobile, and they were a very attractive set of bumpers. I want to talk next about bending square tubing, which really is quite a different animal. We have a piece of square tubing here. This is 3/4 inch square with a 1/16 wall thickness, and I'm going to heat this and bend it around this form. So we'll put the tubing in the trough. I'll get my torch. Okay, we've got it nice and red hot. We'll put this in our fixture and pull it down around. And we've made a bend, but I want you to take a close look at this bend. I'll scrape some of the scale off. You can see that although it's a bend, it doesn't leave the walls of the tubing very flat. It's very cupped on the faces on the inside and outside of the bend, and it's actually rather bulged on the outsides. And I'm sure many of you are asking, well, why didn't you pack it with sand? Actually, I've tried that, and it turns out that with square tubing, packing with sand really doesn't help that much. A round shape is the most efficient shape there is, and any pressures inside it tend to keep it round. With square tubing, deforming it during the bending process tends to want to make the walls cup. So that's the short story for bending square tubing using heat, but I've developed another technique that seems to work quite well for square tubing. Let me demonstrate that next. We're going to use an abrasive die grinder to make a cut about 8 inches long right through the center of the face of this tube on both sides. So I'll put on some safety gear. Okay, there's our cut. We'll flip it over and cut the other side, and then we'll be ready to make the bend. So we've clamped the split tube to the fixture with a C-clamp, and I'm going to use heat on the edge of the tube to soften it while I pull it around by hand. Okay, that's as far as I can go with the inside of the tube. I'm going to get a small C-clamp now to hold the tube to the fixture, and we will heat the outside of the tube and bend it down using the inner section as a guide. I'll be using an adjustable wrench to hold the tubing. Obviously it's a little too hot at this point to hold in my hand. Okay, we've done a nice job now of forming the outside of the tube down tight on top of the inside. So once this is cooled down, we'll clean the scale off it, weld this seam, and then sand it flat. And I think you'll see it's going to make a beautiful bend. So here's the bend all finished up. I've welded it and sanded the seam smooth, and I've cleaned the scale off it with a strip and clean wheel. And you can see it's made a very, very nice bend. Very smooth, very even. And let's compare this bend with the one we made earlier, the one that was not split in half. You can see that this bend has a lot more cupping to it, and the sides are bulged quite a bit on the one that was not split. So obviously it takes quite a bit more work to do it in the way we just showed. You have to split the tubing in half, bend it in halves, and weld it together. But it really makes a nicer job. And notice that the end of the piece of tubing sticks out a little bit on the inside flange. You need to keep that in mind when you lay out a bend like this. Obviously we can trim this off at any point we want. And the bend we made was right at the end of a piece of tubing. There may be times when your project requires that the bend be in the middle of a piece of tubing, and that's possible also. In that case, you simply notch out a section of tubing in the middle, then make your bend in the notched section, and then you cut a strip of metal from another piece of tubing, contour it to fit properly, weld it into place, and finish it. And that makes a very nice job as well. So the demonstration has been with a relatively small piece of tubing, 3/4 inch diameter, square tubing with a 1/16 wall thickness. I've used this technique successfully on tubing up to 1 3/4 inches, and you could use it on even larger tubing as well. And I've used it on rectangular tubing as well as square tubing. So it's a very good technique to know. The next machine we're going to look at is a real moderate cost tubing bender. It's made by Shop Outfitters in Wyoming, and it's designed to bend steel bar, steel tubing in both round and square shapes. Our first demonstration will be a piece of 3/4 inch square steel tubing with a 1/16 inch wall thickness. You just put the piece of tubing in place in the dies and pull the handle around. And it makes a real nice bend. I'll pull this out so you can see what we've done. And there's our bend. If you look closely, you'll see that in order to make the bend, there is some dimpling of both the inside and outside surface, but nonetheless it makes really quite a smooth bend. Okay, let's take a look at some round tubing next. One of the things I like about this machine is the fact that the tooling is inexpensive and really easy to change. We'll get set up for the round tubing dies now. All the dies are held in place with quick release pins. And now we're set up for the round tubing. This is 7/8 OD, 1/16 wall welded steel tubing. We'll slip it into place and pull on the lever. And there's our bend. Really quite nice and quite smooth. There is a special leverage multiplying system that can be used with this tool that allows it to bend tubing up to 1 1/4 in size. Let's take a look at that next. So we have the leverage multiplying device put on the machine now, and the tubing we're going to be bending is 1 1/4 OD, 1/8 inch wall mild steel tubing. So here's how it goes. Tubing is put into the machine. This is kind of a ratcheting type of mechanism. You take one big bite with it, then ratchet this down. We're making the bend a little bit at a time. And there we've got just over 90 degrees of bend. Let's pull this out so you can take a look. and there's our bend. Very nice, very uniform. So this is a moderate cost machine. This is its maximum capacity, 1 1/4 inch. And it's great for small shops or for home hobbyists. Next we'll take a look at a more professional machine. This is a true professional quality bending machine we'll be demonstrating next. It's made by Mittler Brothers in Missouri, and we'll be using it to bend some 1 5/8 OD, 1/8 inch walled mild steel tubing. This is an air over hydraulic machine. It's operated off of a foot pedal. It has a little hydraulic reservoir in it. So I'll put this down on the ground. This is what makes it bend the tubing and then releases it. And the tubing fits into this position here. There's a guiding block that supports the back side of the tubing. There is a yoke that holds the tubing to the machine. And I'm going to put a mark on this tubing right where it touches the yoke. You'll see why this is important in a minute. And then this top piece flips over. And there's a pin which holds it all together. So now we're ready to make the bend. I'll step on the foot pedal. And that's the end of our bend. We'll release the pressure in the cylinder. And we'll take our tubing out. So you can see this really has done a beautiful job making the bend. Very, very little distortion on the wall of the tubing, very smooth bend, and it takes a pretty heavy-duty machine to make a bend in tubing this size with this wall thickness. So one of the things that people often ask at this point is, well, what if you want to make something that has 2 bends in it and you want it to come out to be a particular dimension, let's say 36 inches between the bends? How do you do the layout for that? So let's go to another scene and I'll show you how that setup is done. We've set up a hypothetical situation here. The goal is to bend a U-shaped piece of tubing so that the end result is something that's 24 inches wide and 24 inches tall. And I'll show you how we go about doing that with a fair degree of accuracy. First of all, we'll go back to the bend we made, which has the registration mark on it. And this is crucial. I'm going to lay the top portion of this bend against a straight piece of metal, and we'll measure from this point down to that registration mark. And I'm measuring 11 1/2 inches. And this is the dimension that allows us to make all this come out the way we want to. So I know it's going to be 11 1/2 inches from the top of this U-shaped bend to our registration mark. So we have to know where to start the mark. Since we want the finished height to be 24 inches, our registration mark has to be 12 1/2 inches up from the bottom edge of the tube, or from the beginning end of the tube that we're working with. 12 1/2 plus 11 1/2 equals 24 inches. So I'm going to put a mark on this tube, 12 1/2 inches up from the bottom, and then we'll be lining this mark up on the yoke of the bending machine. Let's go ahead and do that. Okay, we've got the pin in the yoke. Now I'll slide the tube down until our registration mark is right on the edge of the yoke. We've got everything together. Now we'll make a 90-degree bend. There's a scale here that shows how much the bend is being made, and this is a relative gauge. It will change for each particular tubing diameter and for each different set of dies on the machine. But once you've done a test bend, you can repeat that same angle of bend with any bend you make. So we'll release the pressure now. Take our tubing out, and now we're ready to get set up for the second bend. And if you look at the drawing here, you'll see that we want our registration mark to be 11.5 inches away from where we want the finished side of the bend to be. Starting from where we are and working backwards, that means it's 12.5 inches to where we need to put the registration mark. So I will use this as a straight edge. We will make a mark 12.5 inches from that line. Get this set up in the machine. It's very important at this point that you get this leg of the bend absolutely level if you want your bends to be in line. And now we'll make another 90-degree bend. All right. Take the bend out of the machine. And we'll measure what we've got. 24 inches. And this leg is 24 inches. This leg is long. I started with an arbitrary length of tubing that was longer than what I needed, and now that this bend is made, we can trim off the excess. Oftentimes constructions are made of tapered pieces of tubing, and there are a few options for how you go about doing this. There are some pieces of tubing you can buy tapered. Many different cone shapes. This is one example. Here's another. These are great for megaphone exhausts and things of that nature. It's possible to create your own cones. This is a cone I created out of 18 gauge sheet metal. I made a special fixture to roll this cone up. I used a similar fixture to roll a cone out of 1/8 inch thick steel. This is a similar part that's in the process of being made. You can see the welded seam in it. If you have a slip roll, it's very easy to create shapes like these sheet metal megaphones. There are parts you can buy which already have a taper in them. This is chromoly steel, has a very nice taper to it, about a 90 thousandths wall thickness. There is a technique called swedging that is used to create the taper in this tube. It starts as tubing at the largest diameter, and the swedging machine is what causes it to taper. This is yet another example of a piece which has been swedged. Again, it started as a large diameter tubing, and the swedging machine tapered the end of it. Actually, in this case, this was used as a steering component for a race car, and there are internal threads in this part of the tube. So we're going to look at how you can taper your own tubing. We're going to start with a piece of tubing of a fixed diameter. We're going to cut a wedge shape out of it, then pull the edges of the wedge together, weld the seam shut, and finish it. And I think you'll see that makes a very nice part. I have my safety gear on now, and we'll use the die grinder to cut this wedge shape out of the piece of tubing. Okay, there's our cut piece of tubing. Next thing we'll do is to put some hose clamps on this to help to pull the edges together. These are just regular hose clamps like you'd buy at an auto parts supply store. And I'll use an electric drill to tighten them quickly and easily. You know, a lot of people say that the wheel is the greatest invention of mankind. I think it's the cordless electric drill. The greatest force is required at the end that needs to move the most, so we'll put more clamps on that end. When you're at this stage, it's important that you don't get your finger caught in the gap. Okay, we've got it pulled up pretty tight. So the hose clamps have done a nice job of closing the metal up at the gap. And what we'll do next is to put little tack welds at several places along the joint. So I'll hold this in the vise temporarily. Put my welding hood on. And we'll put some little tack welds into place. Okay. Now we'll pull the hose clamps off. And there we have the tube welded up nice and tight. Now if you look closely at the end of the tube, you'll see that we've lost the roundness of the tube. It's kind of a teardrop shape at this point. So the next thing we'll do is to put a mandrel in the vise and tap this piece of tubing into shape over the mandrel. So we have a piece of solid steel bar put in the vise. This is the mandrel we'll be hammering over. We'll slip our piece of tubing over the mandrel. I'll put on some hearing protection, and we'll just start tapping the metal down against the mandrel. And you can see that's done a pretty decent job of making the tube round again. So what's next is we'll completely weld this seam and sand it smooth, and we'll have a nice tapered piece of tubing. So I've just welded 1/2 of this seam and sanded it smooth. I think you can see it really makes a nice job. We have a very even taper on this part, and this is a part you could use for many different applications. Let me show you just one other example of how tubing can be tapered. This is a piece of wing strut tubing or streamline tubing. You can see from the end view that it has that distinct teardrop profile. And I've tapered this piece by just cutting a wedge out of the length, drawing the ends together, and welding the seam. Very interesting shape. This could be used for lots of different applications. The next thing we'll look at is mitering tubing. We're going to start with a piece of square tubing since that's by far the easiest shape to work with. In this particular piece, we're going to make a mitered corner that measures 90 degrees when we're finished. So we need to make a cut in this tube at half that angle, 45 degrees. And I'll use a miter gauge to draw a line on the tubing at a 45-degree angle. Then we'll make the cut in the bandsaw. I'll put on my face shield. Set the blade guide, and we'll make the cut. So each piece is cut at a 45-degree angle now. And when they fit together, it creates a very nice 90-degree angle. There are some devices available that most people are not familiar with. They're little corner pieces designed for square tubing constructions. And let me show you how those can be used. They help you to create a nicely rounded corner in a square tubing construction. They're just welded into place like that. So for certain applications like gates and that sort of thing, this can be an excellent way to treat the corner. So that's the mitering of square tubing. Of course, you can do this at any angle you choose. We just picked 90 degrees arbitrarily. Let's do something similar on a piece of round tubing now. We'll make a mark on this tube at 45 degrees. Now with round tubing, you need to take much more care when cutting in the bandsaw, because the cutting action can make the part want to roll, and it can even roll your hands into the blade, which of course is quite dangerous. So I always use some sort of device to prevent the material from rotating as it's being cut. In this case, I'll use a drill press vise to position the tube as it's being cut. And you'll see that works quite well. So here's a mitered cut in a round piece of tubing. And of course when we fit these together, they will create a 90-degree angle. Basically, for whatever angle of bend you want, your mitered cuts are made at half that angle. And that usually works out quite well. Those are the easiest types of mitered cuts to make. What we're going to look at next is the type of joint where two tubes come together to meet like this. And that takes a fancier cut on the piece which ends in the continuous piece. And there are several ways to make that mitered or saddle cut. The easiest way I know of to do this, on thin wall tubing at least, is to use aircraft shears to cut the tubing. Honestly, it was a revelation to me to find out that you could cut tubing with shears. First time I saw it done, it nearly blew my mind. And of course, you can only do this with steel tubing up to about 1/16 of an inch wall thickness. But you can see, with a little care, you can make a very nice joint. And there are more sophisticated ways to make cuts like this. We'll take a look at one of them in just a moment. Going back to the cuts I made on the bandsaw, probably many people seeing this video do not own a bandsaw. You can do the same thing with a hacksaw with some careful cutting. So you don't need to make a major investment in equipment to do this kind of work. Let's take a look at a slightly more sophisticated way of making these saddle cuts on round tubing. We're going to look at a mitering tool now that's designed to fit on a drill press. These have been on the market for a few years, and when they first came out I was kind of skeptical about them. For years I've done my mitering on a milling machine, which is very rugged, and I use a hole saw to make the coping cut. It works very well on the milling machine because of the rigidity of the machine. And when I saw the ones that worked on a drill press, I just wasn't sure how well they'd work. Well, now that I have one and I've tried it, I'm really quite pleased with the results you get from this. So let's do a test piece using this device. The material we're working on is 1 3/8 OD chrome moly tubing with an 0.65 wall thickness. There's a fixture on the tool into which you place the tubing, and the tubing is tightened into place. This holding clamp can be angled down to 45 degrees. For our particular test today, we'll make about a 35-degree cut. We'll tighten this into place. I'll put my face shield on. And we'll use a little bit of cutting oil on the cutting edge of this hole saw. And there's our cut. I'm going to deburr this a little bit, and then we'll try the fit of this against another piece of 1 3/8 tubing. There we go. And I think in the close-up shot you'll be able to see that this is really an exquisite fit. There is virtually no gap on this fit whatsoever. Very, very nice. So this is a very valuable tool. It's kind of mid-range in price. If you have a milling machine, that might be a little bit better than this, but these work very well. And that's another good way in which you can notch tubing. We're going to take a look at a real high-end tube notching machine now. This one is made by Mittler Brothers, and they call it the Ultimate Tubing Notcher. And actually that's a pretty good name for it because it's a very, very rugged, heavy-duty, purpose-built machine. It's designed for production notching of heavy tubing all day long. It's driven by a 1/2 horsepower motor. The motor runs through a gearbox, so the rotation of the end mill that does the cutting is slowed down. There is a real nice vise with a V groove in it, which is used to hold the work being notched. The vise is on a swivel base, so you can rotate it to virtually any angle. Another real nice feature of this type of notcher is you can make a very, very steep angle with it, which is something that few other types of notchers can do. There's a graduated scale on the base of the vise and a pointer on the vise itself. For this example, I'm going to set it to 45 degrees. We'll tighten it into place with a wrench. And then we'll place the tubing in the vise. We'll tighten the vise securely. I'll liberally apply some cutting oil to the cutter itself and some more to the end of the tubing. We want to be sure we have lots of lubrication because we're going to be removing a lot of material in a short time. I think you'll see how fast this works very soon. I'll put on my face shield for eye protection. There's a switch on the top of the machine I'll use to start it with, and then when the cutter is rotating, there's a hand crank on the back of the machine I'll turn, which feeds the work into the cutter. Okay, this piece of tubing is notched. The tubing I'm using for this example is 1 5/8 OD tubing with a 120 wall, 1/8 inch wall. It's mild steel tubing, and you can see that it only took about 20 seconds for it to fully notch this tubing at a 45-degree angle, and it has made a very, very nice tight fit. So again, this is a rather expensive machine. It might be somewhat out of the range of the home hobbyist. But if you're doing any kind of production work with tubing, a heavy-duty, purpose-built machine like this can actually pay for itself in a short time. Now we'll get into one of my favorite areas of metalworking, and that's working with U-bends. U-bends are available in mild steel, stainless steel, and aluminum, and they come in a wide range of sizes and styles. This is a fairly large diameter U-bend, and this is a fairly small diameter U-bend. And of course there's all ranges of sizes in between. This is a fairly tight radius U-bend, and this is a U-bend with a much broader radius. In most sizes you will have several different choices of radius of bend. There's a special product made called a donut that is a continuous bend. It's not actually bent, it's stamped in two halves and joined together. But this gives you the availability of using a bend much tighter than you could possibly create by starting with a straight piece of tubing and putting a bend into it. U-bends can be cut into sections and joined to create some really wonderful and interesting shapes. This is just a sample I've put together from a few odd pieces of U-bends. And there are a few principles you need to keep in mind when you work with this material so that the flow of bends is very uniform and smooth. What's behind me is my current project. It's a custom Harley-Davidson I'm making a body for, and I've also created a custom exhaust system for it. Let's pull the body up the bike so you can have a closer look at the exhaust system. You can see that the exhaust system has lots of curves in it to clear some of the mechanical components of the engine and frame of the bike, and it's contoured to fit around and exit just in front of the rear wheel. And again, this was created just from U-bends and straight pieces of tubing. So let's take a look now at some of the ways that we cut the tubing and match the cut so you get the smooth, continuous flowing shapes. Usually when you're working with U-bends, you'll be cutting sections from one U-bend and joining that section to a section cut from another U-bend. And typically you'll know what angle you want that joint to be. So let me run through the procedure to show you how I do that. The first thing I do is to set a protractor for the degree of bend we want. In this case, I'm going to start with 45 degrees. We set the protractor on the U-bend, bring it down until we find the point of tangency, and I'm going to mark that with a felt tip marker. So this leg of the protractor is touching the U-bend right at the point where it creates a 45-degree angle. Now this is the crucial step because we can make cuts at different angles that will pass through this point. But the crucial thing is that every cut we make goes to the imaginary center point of the U-bend. So we want this angle to meet this imaginary center. In other words, if we made a cut like this or like this, that would not fit very well against the mating piece cut from the other U-bend. So I'm going to lay this down, mark this cut with a line that goes toward the imaginary center. So this is the layout for the cut that will give us a 45-degree angle. And what's going on with this? Saying that in a different way, if we make this cut at some other angle, when we look at the end of the tube that's been cut, it will not be round. It will actually become an oval. But if you keep all of your cuts going toward this imaginary center, all of the ends will be exactly round, so they will fit together in any orientation. So let's go to the bandsaw now and make this cut. This is a metal cutting bandsaw with a fine-toothed blade on it. And there we have our cut at the 45-degree angle. Now the next step is to take this to the disc sander and just sand this to smooth it a little bit. We're not trying to change the angle. We just want to make sure that this surface is absolutely flat so it will fit very neatly against the next part. So we've sanded this edge flat on the disc sander. And just as one more step of refinement, I'm going to use a deburring tool to get in a little burr off the inside of that. And this is the piece we'll be joining to it, another section of U-bend. Actually, this is a section from a donut. It's an especially tight radius bend. So we're going to join these together at this angle. Now this is arbitrary. I mean, in real life you'll be making a particular part to fit a particular application, and there will be a particular angle that best fits your needs. But we do have the freedom of rotation on this part. It fits perfectly with any degree of rotation we like. And the next thing you'll be faced with is, well, how do I hold this into place for the welding process? Actually, you have quite a few options with that. If you have good access to the part, you really can just hold the piece by hand, and we're not going to weld this now, but you can just tack weld it in place. And it typically takes about 3 tack welds, equally spaced, to hold this piece firmly in place. So that's one option. Another option is you can use masking tape to temporarily hold the piece in place. And although this sounds like it would be very flimsy, you might be surprised to find out how well masking tape works. You can't put a lot of force on these parts, but it holds them in place good enough to make a tack weld. And then of course to actually make the weld you need to peel the tape back. And you'll find that you really can do a decent job like this. But there's a technique that works much better than holding it with your fingers or holding it with masking tape. Let's get set up for that. So this is an ordinary hose clamp that I've cut a little section out of. It's like a little window I've cut. And we're going to put this hose clamp over the part, tighten it just a little bit, and then the piece we're fitting into place can be held very nicely with the hose clamp. We'll tighten this just a little bit, making sure the joint is centered in the window. And we'll get ready to tack weld this. Okay, let me grab my welding hood. And we'll make our first tack weld. And there you have it. And the next step is to rotate this little device around to put the window in the next spot where we'll do our tack welding. Pull it together tight. I'll put my hood on and we'll get ready for the next tack weld. Okay, we'll spin this around for one more tack weld, and that should hold the parts pretty securely together. Okay, ready for the last tack weld. All right. At this point we can take our hose clamp off. And now we're ready to start fitting the next section onto this, whatever it may be. So those are the basic techniques I use for aligning the pieces of tubing during the fitting process. There's a few other aspects of working with tubing I'd like to cover at this point. One of the most interesting shapes, I think, is what I call kind of a bologna slice. This makes a wonderful exit for a tailpipe, and this is very easily made by making an angled cut, just starting with a large diameter U-bend. Very beautiful shape, I think. You can do something quite similar to this with a straight piece of tubing as well, and that again makes a very interesting shape. Quite easy to do. This is simply cut with a bandsaw and then made flat with a disc sander and deburred. Couple other items you should know that are available. You can get bends in this oval tubing as well. This is very interesting material, has a lot of different applications. let your imagination guide you on how this could be used. And a lot of times when you're working with tubing, you'll want to join several pieces together into one common collector. So you can buy devices called collectors. This is a store-bought item. They come in a lot of different sizes. Some of them have 4 inlets, some of them have 3 inlets. And it makes the job, it saves you from doing a lot of work having to fabricate a part like this. But there may be certain situations in which you do want to create your own collectors. Perhaps you want a different configuration or a different look. And that's possible as well. This is a collector I've started to assemble just working with sections from U-bends. I've made cuts on these at 90-degree angles to allow the pieces to fit together. And then these elements will fit into the end of a piece of tubing that I've put dimples in. And you can see when they're assembled, they make quite a nice transition. So there are lots and lots of possibilities of what you can do working with U-bends, and I'm just suggesting a few of them in this video. Let's move on to some other things now. We're in the studio with Mike Cooper in Sebastopol, California. Mike's created a rather incredible exhaust system for his street rod pickup, and he's going to tell us a little bit about the process of creating it. Take it away, Mike.
Okay, Ron. Well, this project started about 3 years ago, but it's been sitting now for about 1.5 years. It started as a 50s style hot rod, one that I had actually ridden in. And when I got started with the body work, the chop and the channel, after that was done, I kind of wanted to do something in outside headers. And what I started with was taking the 4 normal pipe outlets and branching the into 2 additional ones. So I had a start of 6 pipes. And with the addition of about 46 U-bends, I have a pretty elaborate header system which goes into this collector. There's a large baffle here which can be held in place with this mounting system. So in normal use it would go through the pipe, through the frame, through the muffler system and to the back. This started with more of an emphasis on design rather than function or racing purposes, since that's more of my interest. And what I started with was U-bends about this size using 3 different radiuses. And I would usually just cut them in various segments of an arc from 180 degrees down to as little as 15 degrees, and then reconfigure them something like these 3 pipes here, so that you can maneuver the pipe to go any way you want. Move it around pipes, move it around body parts, get close, get more distance. Just create a visual look that's satisfying. And after a fair amount of time went by with playing with different shapes, these were all more or less taped together and held in place. Then I started a little bit of welding. At the point where I started to do this large collector, I wasn't quite sure what I wanted here, but I did some sketching, and it turned out to have a kind of a look, this tapered look with these recessed bolt holders. Kind of had a Buck Rogers look, which I really liked, something kind of out of the 50s. And this is a tapered cone made of 16 gauge steel. I made a paper pattern and then rolled this in a 3-inch roller to get a cone-like shape, and then welded the back side. Has an additional heavy flange on the end. Well, after the headers were done, I started laying out the pipes going back, and the plan was to have the two pipes going to the side and eventually coming together into a single pipe right behind the tailgate. So when I got the muffler comes back to here, right underneath what will be the gas tank. This has a 2-inch section of pipe which goes to about here, one single U-bend, and then I had made a kind of a bell shape using a press brake to step that up to a 2.5-inch section. So that comes around, goes underneath some of the frame to another flange section, and then from here I again made a large taper cone. This starts from 2.5 and goes to 6 inches. And here's where it got real interesting, because I love the effect of tubing when you do join things. And this was splitting a single U-bend, and with it split and then putting it back to back, you get this beautiful section that comes together, and then it does a nice swoop, which is all manufactured out of truck exhaust. My goal was to have a single exhaust. This is 6-inch truck tubing, 16 gauge, and this is kind of tricky to work with because it's neither quite round, nor when you cut it and then reconfigure a piece does it usually fit right back together. You have to usually cut some little pie-shaped darts, almost like you would do in making a dress, I guess. You cut little sections out, as many as you think you need to gather that back together to get a transition from one pipe right into another. And it's kind of fun because it's not that difficult, but it's challenging, and you have to be a little bit careful about tacking and going on. So this had a lot of that kind of massaging. The first side was done completely in the car, and that had to be done that way just to get clearance correctly over the fender and get the pipe running through the body, through the frame properly. But after doing that one section, I was wondering how to do the other one to match. And I decided to make a simple wooden fixture like this, which has a center board to support the flanges. And that worked out really well, because after you mount one side complete, you can start with the other side, and you can make little furniture pieces that will hold a pipe up to the correct height as you have on the finished side. And you can use measurements from the center line out to capture the relationship of height to length. So it wasn't too difficult to make that second half to match. Again, though, what I was trying to do was get more pipes to give it a more of a design effect, and I did a unit like this, where in this case the front pipe here has the forward pipe is the pipe that is carrying the exhaust gases, and the other one is a complete dummy. So it was bird's mouth, something like this, and those were joined together to give that effect. And then that allows you to pick up a wonderful bunch of design elements where you have pipes that might cross over like this and give you other relationships that would be impossible or just not quite as interesting with fewer pipes. And that's about it. I've enjoyed having the time to share this with you, and now I just can't wait to see what this thing's going to sound like. We want to drive it. Burn, burn, burn.
Well, we've come to the end of our videotape on working with tubing. I hope you've all learned something from the video. I really enjoy working with tubing. It has so many possibilities. I think once you start using it, you'll find more and more ways to use it for your own particular applications. So until next time, this is Ron Covell. We'll very gently tighten the vise and then pull the filled aluminum tubing down over the form. Yeah, well, cut. Time to go home now.